Assalamualaikum and hi guys, welcome back to our channel Kari Present, the Logic War, Project Discrete Structures. I'm gonna introduce you our superheroes. First, we have Azhan, the Logic Lockdown. Second, we have Danish, Connective Crisis. And we have me, Iman Fateh, Proof of Possibility. And lastly, we have Sameh, the Logic of Right. Our lesson objective is to uncover the truth behind every statement. Using the power of logic, our heroes will decode complex propositions, battle contradictions, and reveal the hidden structure of truth. Firstly, you need to understand how logical statements work. Next, master the use of and, or, not, and other connectives. Next, build and analyze truth table. Next, detect logical equivalence and contradictions. And lastly, we need to understand solve logic-based problems like a real heroes.
Hi, I am Azhan, the Logic Lockdown. What is logic? Logic can be described as the discipline that examines valid reasoning. It ensures that if the premise of an argument are accepted, the conclusion must also be accepted. Barwis and Etchemendy says all rational inquiry depends on logic, on the ability of people to reason correctly most of the time, and when they fail to reason correctly, on the ability of others to point out the gaps in their reasoning. The philosopher of logic, the first one, Aristotle, the father of logic, Gottfried Leibniz, George Boole, and Augustus De Morgan. There are statement or proposition. Statement or proposition is a declarative sentence with the value of true or false, but not both. There are example below shows 6 example. 4 from them is statement and 2 not statement. The 4 statement is the world is rectangle, 3 plus 4 equals to 7, whale is mammalia, the sun will shine today. And not statement is come here. Why is it is not statement? Because it is command. Will the real Slim Shady please stand up? Is not statement because it is question.
Hello guys, here with me, Danish, the Connective Crisis. In this part, I'm gonna help you understand what is the frame of logic. So the first is, statement usually will be replaced by variables such as am, and, o, or p. So the example is, am is whale is mammalia, and n is the sun will shine today. So the second is, statements can be combined by logical connectives to obtain compound statement. The example is, and open bracket P and Q close bracket is the sun will shine today and it is a cold weather. So then we need to understand what is or and what is and. Connectives or is what we call disjunction for P and Q, written P or Q. The compound statement is false if both statements are false. So the next is, connectives and is what we call conjunction for P and Q, written P and Q. The compound statement is true if both statements are true. Here we have the truth grid, also known as truth tables. It helps us find the true value of statement, especially when we have two statements combined using logical operator. In this table, P and Q are two simple statements, which is T means true, F means false. The first two columns show all the possible combination of truth values for P and Q. For the third column, it is only true when both P and Q are true. As you guys can see, it's only true in the first row. And for the last column, it is true when at least one of P or Q is true. As we can see, it is true in every row except when both are false. So, on to the next part. Negation for any statement P is not P, written as not P or P. The truth table for negation is P is true false and not P is false true. So, let's answer a question together. The question is find the value of not open bracket P and Q close bracket and not P or not Q using truth table. In this question, we need to using the Morgan law. Not open bracket P and Q closes bracket equal to not P or not Q. In this question, we are finding the value of not open bracket P and Q closes bracket and not P or not Q using a truth table. First, we list all possible values of P and Q. Then, we find P and Q. This is only true when both P and Q are true. So the next, we take not open bracket P and Q close bracket, which is just flips the value from the previous column. We also find not P and not Q. Then, use them to get not P or not Q. From the result, we see that not open bracket P and Q close bracket and not P or not Q give the same truth value. This matches the Morgan law, which is not open bracket P and Q closes bracket equal to not P or not Q. So in this part, I'm gonna talk about conditional statement. For the first point is, if P and Q are statement, the compound statement if P then Q denoted by P then Q is called conditional statement or implication. Second point is, statement P is called the antecedent or hypothesis and statement Q is called consequent or conclusion. The connective if then is denoted by the symbol then. So we have two examples, A and B. A, P, I am hungry. Q, I will eat. And for B, P, it is cold. Q, 3 plus 5 equals to 8. The implication would be A, if I'm hungry, then I will eat. For B, if it's cold, then 3 plus 5 equals to 8. So take note that in our daily life has no connection between statements P and Q. That is, statement P has no effect on statement Q. However, in logic, this is acceptable. It shows that in logic we use conditional statement in a more general sense. So here we have the truth table. Let's look at the table. When both P and Q are true, the whole statement is true. When P is true but Q is false, the statement is false. This is the only time it's false because Q didn't happen after P. When P is false, the whole statement is always true, even if Q is also false. This might feel weird, but in logic, we only care about when P is true. If P didn't happen, we don't blame Q.
Hi, my name is Samil Logic Override. Firstly, I'm gonna explain about symbol and I will make sure you can understand. Another meaning that use the symbol arrow includes if P then Q. P implies Q, that's mean the arrow pointing right. If P then Q or P implies Q. Continuing to the next slide. If P then Q is an implication, then the converse of it is the implication Q then P. And the contrapositive of it is not Q then not P. And the inverse of it is not P then not Q. For example, you can see we give the 4 example. So, first, P then Q. If Nemo is a cat, then he is an animal. Second, P, Q, then P. If Nemo is an animal, then he is a cat. Not P, then not Q. If Nemo is not a cat, then he is not an animal. Fourth, not Q, then not P. If Nemo is not an animal, then he is not a cat. From here, you can understand that P is cat, Q is animal. And if they have the not symbol, you should put the not in your text. So, you can see in the slide, example, we give P is equal to it's raining, Q is equal to I get wet. So let's see the output. If P and Q are statements, compound statements P if and only if Q, denoted by P only if Q is called an equivalence or biconditional. To understand, use P, it is raining, Q, I use an umbrella. Notice that P only if Q is true in two conditions. Both P and Q are true or both P and Q are false. So you can refer the truth table that beside. Another meaning that use the symbol only if includes P is necessary and sufficient for Q if P then Q, and conversely. In general, compound statement may contain few parts in which each one of it is add a statement to. Example 7. Find the truth value for the statement bracket P then Q bracket only if bracket not Q then not P bracket. As you see, here we have the truth table. To understanding the tautology through a truth table, this table explores the logic relationship between two positions P and Q and how their combination led to compound statements. Column A shows the implication P then Q. Column B shows the implication not Q then not P, which is contrapositive of A. The final column A only if B checks if both implications are logically equal. And a tautology is a powerful concept in logic, ensuring reliability across all scenarios. As you can see in the slide, a statement that is always false for all possible values of its proportional variable is called a contradiction, P and not P. A statement that can be either true or false, depending on the truth values of its proportional variable, is called a contingency, bracket P and bracket Q, and bracket P or Q bracket.
Hi guys, it's me again, Iman Fateh, proof of possibility. Now, I'm gonna talk about logically equivalent. First, two statements P and Q are said to be logically equivalent if P by conditional Q is a tautology. Next, X show that statement P then Q and not P v Q are logically equivalent. Do you guys know about quantifier? Okay, I'm gonna explain to you guys what is quantifier. Quantifier is used to define about all elements that have something in common, such as in set. One way of writing it is X, P, open bracket X, close bracket, where P, open bracket X, close bracket is called predicate or propositional function, in which each choice of X will produce a proposition P, open bracket X, close bracket, that is either true or false. There are two types of quantifier being used, universal quantification and existential quantification. Universal quantification of a predicate P, open bracket X, is the statement. In other words, for every X for any X. Assume that only values of X that make sense in P, open bracket X, close bracket considered. In existential quantification of a predicate P, open bracket X, is the statement. Assume that at least one value for which a predicate is true. In other words, there is an X, there is some X, there exists an X, there is at least one X. Okay guys, lastly, I'm gonna show you guys the example of operation of the statement. First, we have commutative. Secondly, we have associative. Next, we have distributive. Next, we have idempotent. And lastly, we have negation. And that's all from us. Bye. Thank you.
Audio Jungle.